Recently, with LDO Motors, we have released several toolboards. Let me show you something about them. So this is our toolboard for the Orbiter 2. Here it's assembled on the orbiter together with our new sensor. It's an interesting new sensor design. This one is for the Smart Orbiter 3. And here you can see it connected to the Orbiter 3 Revo version. And the last one, the guys from E3D really like my toolboard design, so they asked me to design one for their new Revo extruder. And here you can see it mounted on the Revo. Super cool extruder and toolboard. Why is this toolboard different than any other toolboard? Because it has lots of protection features, like short circuit protection at the hot end outputs, at the fan outputs, at the sensor inputs, outputs. Basically all the inputs and outputs are short circuit protected and ESD protected. Even this USB port, it's protected against short circuit between the power supply line and the USB, so the toolboard will not be destroyed, and even more, your Raspberry Pi will also not be destroyed due to this small adapter circuit which has the protection feature on. And we have also a huge heatsink to cool down the MOSFETs and the onboard microcontroller, so we have the highest possible temperature at which we can operate this toolboard. I have here a small setup which I would like to use to show you some of the protection features. So what I've done here, I just hooked up some fans. During the testing I used a 100 watt heater from LDO. This is a Voron V0 heater. I have the toolboard set up and it's connected to another board which is a secret I'm not allowed to tell you. I'm an automotive electronic designer. In automotive, our electronics must survive to any kind of failures which might happen, including short circuits. Yeah? And in this toolboard I integrated many of these features which we use in automotive technology. Let me show you. For example, I would just turn on the fan. This would be the cooling fan. Now hear the noise and you can see that it's moving. I have two fans here connected. This is the fan output. And look, I can make a short circuit at the output. The fans will stop. You see, it's not turning anymore. If I remove the short circuit, it will start back up. Circuit detects a failure, reacts by protecting the output circuit, and after the short circuit is removed, it restarts and nothing happens. So this is a typical failure. It can happen in any printer. So you can have some wires broken, or by mistake you shorten the wires and you don't want your toolboard or your electronics to be destroyed. And that's what this toolboard are about. Same with the tool fan. You can see here I started the tool fan. I can make some nice short circuits over the connector, make some small sparks. Fan stops, releasing, fan will start back again. I can do it many times as I want. Nothing will really happen. Of course, I will not advise to do it this very often. It is designed to protect the circuit, but it's not designed to have hundreds of short circuits just for fun. The hot end heater output also has short circuit protection. Let me show you. So I have here the toolboard hooked up to a 100 watt heater. Now this is not a hot end, but for the test it doesn't really matter. It just we need some load, and this is what I used during the test to simulate high power hot end. And what I do here now is let's activate the heater. So now you can see the LED here, it's on, so the heater is heating. And look here, I can make some super nice sparks. With this screwdriver I can make a short circuit to the output. You see? Nothing happened. Make some nice sparks. The LED goes off, so the short circuit is detected, the circuit is protected. And if I remove the short, the circuit will work again and the heater will heat again. Of course, if this is happening too many times, the clipper will give an error because of temperature runout detection, but that's normal.